Hi, hello, namaskar. This is your host Sarang, and welcome to One Story at a Time. In this podcast, we have with us Mr. Bhargav, who is an ASIC design engineer at Synopsys, placed at 16.5 lakhs per annum from BMS College of Engineering. Hi, Bhargav. How are you doing? Good, good, good. And first of all, congratulations on graduating, and congratulations on getting placed at Synopsys. Thank you so much, Bhargav. How was your 4 years of engineering?
So I would say it was one of the best. Yeah, there were some high and lows in the journey, but I'd say when I look at myself the day I entered college 4 years ago and today where I stand, I feel I owe a lot to BMS and also there's a lot of change in myself, the way I think, the way I look at the industry and also myself. It has changed a lot. So it has been a great journey.
Right, I mean, I can truly agree with you on that. In some way, BMS has changed me as well. The kind of person I was when I entered BMS and the kind of person I am today is all because of BMS and the kind of network and connections it has given me. All right, so let's jump into the podcast right away. So the first question to you is, I mean, I've asked the same question in the previous podcast also, but still, why engineering and why electronics and communication?
So I would say this the reason why I chose electronics basically goes back to around 6 years now. Like when I was in PUC, when I had to opt between three courses: biology, electronics, and computer science. These are the four subjects that are offered. Biology was not on my list from the beginning, but electronics was something which fascinated me from the beginning. So that option of choosing electronics there, from there it has took me over 6 years of this journey where I'm here today working in electronics itself. I would say that's why it was electronics. That time it was just an option for me, but now it's a choice. And engineering, to be frank, once I chose electronics, I knew I was getting into engineering. I've heard a lot of people say engineering is a course which is done by crowds and it is not fit. It is. There's a lot of uh, things that about engineering that is not effective. You don't find jobs, all of this. But despite all that, yeah, I wanted to choose engineering and I am here. And to this day, I don't have any regrets. I'm very happy I chose this. I don't know if I would be this happy and satisfied if I was in another course as well. So I would say engineering and electronics has been my choice, and for now it has turned into a passion also.
Oh, that's great. I mean, uh, you knew what you wanted to do right from second PU. So that is kind of great, and not a lot of people know what to do when they are in 12th or 11th. It's really good that you had figured it out long back. And I mean, after choosing electronics in PU, I think it was obvious for you to choose engineering, right?
Yeah, that was obvious, but I wouldn't say I was regretting that option, but I was very happy that somehow accidentally I chose the right path for me. So there's no regrets in that way.
Right. I mean, being an engineer, I think you've turned out pretty well and you're doing good for yourself.
Yeah.
So let's talk more about electronics and communication, and then we'll come back to your placement journey and all those things. So, a lot of people think that electronics is only about mobile phones or chips or uh, you know motherboards inside laptops or computer or whatever it is. Tell us more about the various domains which come under electronics and communication.
Okay. So yeah, that's a wrong judgment to say that it's all about mobile phones and chips. Yeah, I wouldn't agree to that. So if we look at today, right, electronics and communication as a domain, you can point to I think every device at your house or anywhere you go. It you can find one electronic device or communication device in that for sure. I can assure that.
Mm.
Like if we see automobiles these days, before they used to be just mechanical components. Today we see electronics in them also. It ranges from just a small watch or any smart device from that to space shuttles. Everywhere electronics is there. And I think electronics and communication, right? This is a proper blend of two domains, I would say, because wherever you use electronics, communication is must and should there. So it goes hand in hand. So if I want to talk about electronics as a domain and the various subdomains that are there in electronics, for an engineer, I would say it starts from the core where you design or fabricate things. From that stage of physical design of a chip or any IC, from there it goes on to the next level of front end design. From there, once the front end and back end are developed and the IC is fabricated or a chip is fabricated, from there an embedded designer will write a firmware for this chip in order to integrate the software and the hardware. And we also have embedded software engineers who write software for this, compilers, such things. So that way, electronics spans across the entire range of material science and physical design to digital design, that's Verilog and system Verilog. And then it comes to firmware design, where we write drivers, we write firmware, and then it comes to software design, where we write compilers and the higher end softwares. So that way it spans
Mm.
across all scales of uh, design. And then if I have to talk about communication, right, there are a lot of scope. There's a lot of scope for communication in electronics. Then if you look at a chip or an SoC, there's an inter-chip communication. Yeah, there's communication between the chip and other modules. There's a lot of scope in that place. And also, apart from that, antennas, these systems being incorporated in automobiles or even for space shuttles, there also we use a lot of communication aspects. That way, I think electronics and communication is a perfect blend for an engineer to dive into this field of VLSI industry or automobile industry, like this any domain. I think an electronics and communication engineer at this date fits to any of the on any of the domains, and he will find an application there for sure.
Correct. I mean, it's good that you pointed out an example wherein, automobiles were mostly made up of mechanical components, but now a lot of it is electronics also. Say, for example, you have internet cars, you have connected cars, you have autonomous cars, which, is mainly run by electronics and, computer science. So it's really amazing how electronics has evolved as a subject, how electronics has evolved as a technology. And so, from what you said, what I can concur is electronics. Under electronics, it's basically designing, which is your VLSI, and then it is your embedded systems, which is basically your ICs and circuits, and then comes firmware development, which is nothing but the software, Verilog and HDL, and then comes communication. So that is basically 4 or 5 major domains under electronics. Correct?
Yeah. True.
Great. Tell us more about your favorite domain. I'm guessing it is embedded systems.
Okay, so yeah, to start off with, I would say that was correct when I was in probably my end of first year towards the beginning of second year when I was introduced to my department. Right? Yeah, embedded systems, this robotics domain, these were something which fascinated me, and I would believe it fascinates most of the people because by then we wouldn't have been introduced to actuals of VLSI, anything like that. So I would say to start off for an engineer, embedded systems should be his interest because that's where uh, you're masked from the details of the design of a chip and you're allowed to use the chip and all this ICs and systems and also integrate them into an application which you want to build. So that way, embedded system provides a platform for beginners to learn the
Mm.
domain of electronics. But once you move more into electronics domain, probably towards my third years of ending, yeah, third years I would be specific. So that time I would believe we have to dive more into VLSI industry because without the chip or the IC being fabricated, there's nothing in embedded systems. So I'd say embedded system is also my favorite, but today, if you ask me, then I would say design because that's where my expertise is, and also that's where I see my future also.
Correct. Amazing. Because the reason I said embedded systems is because I think very, very long back we had discussed on conducting an embedded system workshop with WAC. So that's the reason I said
Yeah, true.
embedded system. I started with design because I used to work at a startup called Be Automate. So we used to conduct workshops
Yeah.
on dip trace, which is basically an EDA. So I was also into designing very, very, very initially, but then I lost complete interest on electronics after I got into third year. uh, actually, I this microprocessors and microcontrollers fascinated me a lot because it's amazing how those small chips can do wonders and how much they can compute and uh, how much big amount of data they can compute in micro and nanoseconds. So that is what fascinated me to get into electronics. But today I'm into a completely different domain. So coming to the question, the reason I told you this is, uh, what kind of people do you think should apply for electronics and communication engineering?
Okay. So yeah, I wouldn't say that's wrong. Like everyone has their passion. Everyone finds their passion at some point in their life. It's good that you have found this position and the place you are. I think it's great and you fit in very well. So there's nothing as such like what kind of people should choose electronics.
Hmm.
Electronics and today I would say engineering as a industry itself is multidisciplinary and every discipline is interrelated to every other thing. So it's all about what interests you more and what interests you less. That's it. You cannot say something is not my interest and be an engineer. I cannot say I don't know coding just because I work in a real estate industry, and I can't say I don't want to learn mechanical aspects because I'm in real estate. Just in case I get into a product where automobile is being built, then I would have to know some amount of mechanical to integrate some mechanical components in using electronics. I might have to know some amount of software for me to explain the electronics and how I want the software to be returned to the software designer. So that way it has become interdisciplinary. And I would say electronics somewhere sits between uh, like computer. I would say when people get into engineering, right, when they have to choose their domain, they'll be stuck between three domains as far as I've seen. That is computer science, electronics, electrical together. I would say electronics cluster and mechanical. So if you have to choose between these three, right, computer science would be for a person who loves to code, who loves to debug things. That would be a point where you have to choose computer science. If you're fascinated about how devices are built, how they work, then you have to get into electronics. And if you are fascinated about building things and making things work, then yeah, mechanical is also very good. And mechanical, I would say, is more multidisciplinary than any other domain. It almost penetrates into every other domain. And electronics also is achieving the same status in this date where it's being penetrating into every other domain. And computer science, as we all know, it's like the reason why it's so famous today and has so much hype is because we see software needed everywhere. How much ever the hardware is robust enough, you have to have a interface for the user as well. So that's why these three domains, as I see the most popular domains in engineering, are very interdisciplinary. So I wouldn't boil down to why someone should choose electronics, but wherever you go, you will again end up working with electronics people, or you might also want electronics knowledge as well. But if electronics, the knowledge of chips, designing these transistors, all of this excites you, just the point that you will be able to design something which you have been seeing around you from your childhood. If that fascinates you, then surely you should go into electronics.
Amazing, amazing answer. I mean, I can definitely agree with you on engineering being completely interdisciplinary. Doesn't mean that if you take electronics, doesn't mean that you should not know anything about computer science. It is always good to know things from other departments, other domains as well. That's what gives you an edge over your peers or over other engineers when you look through placement perspectives, right? So I mean, I have known you right from first year, and I know that you have worked on a lot of projects. You have conducted a lot of workshops in college. So tell us more about the kind of projects you did and the kind of resources that were needed for the projects, because a lot of people have project ideas, but they don't have the right resources. So tell us more about that, your projects, and how did you get resources for your projects?
So if I look at my project side, I can easily map it to the subject that I was studying at that point in engineering. So at the beginning of first years, I was just interested in learning about engineering because in first years we are introduced to almost all domains. So I was just trying out some codes in C, and also I was trying to learn more about transistors or electronics and electrical as a domain as well. When I stepped into our department in second year, and that's when we had our first project to be presented. So at that time, we weren't introduced to design perspective of VLSI. So I took up the project of just making a small microprocessor design. So I'm using ICs, the ICs, standard ICs that are available. So these ICs are easily sourceable. It will be available in every college, I'm sure. And also it can be sourced from various online, offline shops, and they are very cost effective as well. So these chips, right, they provide you basic functionality and it will help you design some logic circuits using these ICs. It was a very simple project, and yet it helped me learn how externally I can use these ICs and try to build logic circuits. And that was what we were learning at that time as well. We were learning about analog electronics and digital electronics. Digital electronics speaks more about how we can use ICs and logic gates to build complex digital circuits. And analog, as a, a, a subject, tells us more about how these gates or ICs are working inside and how these gates internally produce this digital logic. So that way, that project helped me learn more about how logic circuits are designed. And then towards the beginning of third year, probably like I took up that time, I was more introduced to HDL as a domain, that is hardware description language, Verilog and system Verilog to an extent. And we were also more keen on developing some design from scratch than using standard ICs. That is when we took up the project of designing an image signal processor. Yeah, before that as well, we had worked on projects related to small processor design before we stepped into this. That was a RISC architecture based processor, a simple processor with probably around 16 instructions. And we also had implemented I2C, which is a communication protocol, and as well as AES encryption. The main reason why we did this is because these two protocols were not integrated into the hardware. They are uh, available as external IPs, whereas integrating them into the hardware of your IP itself will give you less latency and faster operation. So with this in mind, we tried out that as well. That project helped me learn more about the protocol and how we design IPs, but to a small extent. Then we came up with the idea of image signal processor. That is a processor which takes in raw image from any camera source, probably this feed as well, which is displayed on our screen, and also any other DSLR camera feed, anything. And it processes that image to give a clean image. It had 9 operations in its pipeline, and the pipeline would process the image. This way, image signal processor introduced me partly into the image processing domain as well, learning about various image enhancement and image processing operations as well. Because that time we were learning more about DSP and the signal processing domains as well. So that is the reason why we chose this. And then I wouldn't leave HDL as well because that was my interest. I had found my interest that I myself that HDL and VLSI design as a domain was very fascinating to me. So we merged both of them and got it into a project that was towards the end of third year. Then in fourth year, when we came, yeah, I would still say we wanted to work on HDL, but this time we wanted to aim for a novel approach. Till now, whatever projects I've mentioned have been towards implementing something which is already present.
Mm.
This time we wanted to aim for something novel and research on it. So that's when we chose a system level router module, which will help route between different IP modules which are present on an SoC. And this was based on a routing module for network concept. So this was our final year project. Yeah, it
Mm.
went very well. We came up with a good approach, and the results are doing great. And we'll be publishing it soon. And I'll probably share the publication with Innovact as well.
Mm.
So these are the set of projects I did in the core domain. That is the domain where I work in. Apart from this, I've been a part of a lot of other projects in my internships as well as at competitions. So towards the beginning of second year and third year, well, yeah, we worked on Yantra as well, which is a competition conducted by IIT Bombay for young entrepreneurs, young engineers who want to develop their skills in robotics as a domain and embedded systems as well. So it
Mm.
was great. We participated in it for 2 years. The first year we had to build a bot
Mm.
which uh, complete a proper manual around a circle and it did some tasks. The second year, we worked more on ROS as well as Gazebo platforms to develop a kind of interface, or I would say a product, to be frank, which is an automatic warehouse, which would automate the warehousing that we do. This has a lot of applications in probably I would say Amazon or Flipkart. These large marketplaces have their I would say
Mm.
warehouses where they had to automate these boxes being sent and out, and it has to be notified to the user. That way, that project also helped me learn more about ROS, which was a new domain for me. That's robotic operating system, and Gazebo platform as well as a simulation platform. These two projects, or I would say competition, helped me to learn a lot more about robotics as a domain. And apart from this, we also had uh, proposed a project to IASC that through their Art Park Mini Grant Challenge, wherein
Mm.
we tried to propose a soft robotic uh, soft robot with robotic arms, which is used for underwater exploration and garbage collection as well. Yeah, we were one of the two teams which got the grant from BMS College, and it went on very well. We did the project for around 8 months, and then I would say in my internships, my towards the initial days, my internships were mostly about software, image processing, and these domains. My first internship was in a business process automation domain, wherein I
Mm.
worked on automatic invoice parser, which will process invoices automatically for any client working with manual data entry. This software with its robust backend would provide a platform to automate data entry. Then I worked with Honeywell on an IoT based application in automating their web application testing. Then now I work with VLSI IP design. So that's all about the projects that I've been part of in engineering. Yeah, it spans across various domains, and I would say everyone should try to explore various domains because that's when you'll understand where your interest is. Because just narrowing down to saying that yeah, this feels interesting and this is my domain isn't correct. You have to explore everything. So be it software, embedded design, be it VLSI design, robotics, everything you have to explore, and finally you'll find your interest somewhere.
Great, amazing. I mean, uh, the I think I have mentioned this in the previous podcast also. It's not about learning theory. It's more about implementing it, and it's more about the practical applications of what you learn. So I can definitely see that in you because the number of projects you have done and the kind of projects you have done itself tells you how good an engineer you are. And I must also say that it was very interesting for me to listen that you were doing projects based on what you were learning in your engineering because not a lot of people go in this way because I've known a few people. There are two kind of people who I know. One of them who does not give a shit about engineering, so they just want to do engineering, pass, get a certificate, and go. And the other kind of engineers are very fast forward. So if now let's say they are in first year, so they learn. I mean, this is about computer science, but if now they come into first year, they start learning Python, machine learning, and artificial intelligence. But in your case, it's very interesting to know that you did your projects based on what you were learning in your college. So that probably that is one thing I think that all engineers must follow, because in labs you do get an opportunity to work on small, very mini projects, very small projects. But I think people and engineers must encourage themselves to work more on projects, on simultaneously on what they're learning in their college, so that will even enhance their level of understanding the subject. So that's really great. And I was also a part of this Yantra competition. Even I was working on ROS and Gazebo, but
Yeah.
after some time I realized that is not for me. So I had to kind of quit that Yantra competition in the middle. And tell us more about this grant you got funded from IASC.
Okay, so Art Park Mini Grant, Art Park is a subgroup in ISC which works with artificial intelligence, image processing, and machine learning domains. So they come up with this mini grant challenge every year, wherein they call for ideas which require grant, probably most preferably the final year projects of engineers.
Mm.
And they'll completely fund your project and also pay you every month for doing the project that you are interested in. So that I would say that's a great opportunity for an engineer to work on what he's interested in and as well get paid for it and also get funded for the project. So it was a great opportunity. We never assumed that from ISC, out of all the competition, we would get selected, but our idea had the potential and it got selected and we worked on it. I mainly worked on the electronics part of it.
Mm.
I have my fellow mechanical friends and computer science friend who worked on this. They are my teammates. So as a team, we worked very well and we could make a good amount of progress. However, after around 8 months, due to some miscommunication and also some time differences because of our internships, and I would say mainly because of our internship, we couldn't contribute much to the project. That's when we dropped from the project. But I would say for a project, right, there's nothing, it's not binary. It's not a pass or fail, something like a theory subject. In a project, it's all about the journey, how you explore the topic, how you learn things, and how you find out how the result is. Even if the result is a fail, right, you'll still end up learning things. And I would say this IASC example that I gave you, right, it's the best example because for 8 months we worked on a project and we dropped it, but still that in the span of 8 months, what I learned about robotics and the amount of papers we read about and things like that, I would say that's the one of the best learning. Even if the project passed, right, I would still have the same amount of learning. No one should aim for a project to be a successful project. You just have to aim to work towards the goal. Even if it's a failure, you'll still learn things. And I would say, like, not all of my projects have achieved what wanted them to be as well. But I would say they are they are what make me what I am today. So they have taught me on how I should explore a project, how I should take up an idea and explore how to make it into a product or a research work. So that's the cycle. You learn, relearn, and try making new things. That's it.
Okay. So it's not about the project or the product, it's all about the process, is what Bhargav is trying to say. And I also
True.
think in that terms, because since I got into stock trading, I've been doing it for almost 1.5 years, which is not easy at all. And uh, people think
True.
that stock market, if you get into stock market, you can be a billionaire or a millionaire in 1 year, 2 years. It's absolutely not like that. So that's when even I shifted to this kind of mindset where I trust the process. I believe in the process rather than, like just thinking about what is going to happen in the future, how much money I'm going to make in the future, and so on. So, I mean, as you said, it's all about the process, just not about the success or failure of the project or a product. That's great. And I also mentioned this earlier in the podcast that people have project ideas, but then they lack the resources, they lack, it might be funds, it might be teams, it might be guidance, and so on. So I believe that, since your experience, Art Park has been a wonderful platform and an opportunity for you to work on projects which you are interested in. And in the same way, they funded you and they guided you towards completing the project. So that's one good thing that institutions like IAC and BMS are promoting. Right, and also one more heads up to our viewers: if you are working on a project or an idea, and if you are looking for a team or a mentor, download Innovac Social, wherein you can find the right team and the right mentor in just 2 steps. So this is my subtle way of marketing Innovac in the podcast. Right. So
No, that should be there. It's always good when you're making a product and you don't market it. I think you're doing something wrong. You should be proud of it. And I would say I'm very proud of the product. And I always have believed in your dream, and I wish that it is a success. And I'm very sure it will be a success.
thank you, thank you. That was very encouraging. Okay, now let's come to this placement perspective and placement funda. One thing I've observed, and I think a lot of our viewers and yourself also would have observed, is the ratio of people getting placed in core companies and the ratio of to the number of people getting placed in mass recruiting companies is very, very, very significant. Why do you think that there is a significant difference in the way that people are getting placed?
Okay. So I would say the reason to that is your interests and the way you see engineering and your goals at engineering. Okay. If you get into a mass recruiting company, I don't want to take names, but any of the mass recruiting companies, there are a number of them who do that. They are basically hiring a workforce. If they are hiring around 200 to 50 people in a lot, how significant would your presence be in the company among those 250 people?
Very less.
First, the person has to think about that. Whereas in a core company, right, no one will take in large numbers because the workforce they need is less, but the skill and the quality of that workforce is very significant to them. That's where the difference starts. So if you are, I wouldn't say it's wrong to get into a mass recruiting company. It is fine. It's all about what you want to take up in. Like some people like don't want to take engineering as a mainstream in their life. They want to take it up as a source of income probably, and then take up some other interest in their life for their mainstream passion. Yeah, that is fine. The people who go into that category are good to go. But if you are an engineer and you believe that engineering is your bread and butter and this is what makes you what you are, then you should be in a core company. I wouldn't say software companies are not core companies. There are companies which work on core software development and they hire in very few numbers. The key is that when they hire in few numbers, right, that's when they want a workforce which is very skillful and effective, and that's where you should be. When the numbers are less, you get more importance and more work. When the numbers are more, you get less recognized and your impact in the company will be less. And I would say I've been through software cycle as well. For around 1.5 2 years I've worked in software as an intern, be it in business process automation or as a software automation tester. In both the places, right, software as a domain is also very good. You get a lot of importance in that domain as well. And in electronics, where I work today as well, this is a place where impact I see is in large numbers. One IP design and one breakthrough in an IP design can make the whole world look different, and the way processors work and the processor industry or the VLSI industry works. So this is more impactful in my opinion. So that way, the yeah, to sum it up, the main reason is just about passion and
Mhm.
your skill set. If you are passionate, then you should aim for a company which has in less numbers and make a difference there.
Correct. I mean, absolutely true. Because I had a mentor called Arfan. Have you heard of his name in college? He was,
Yeah, yeah, I know.
you know him.
He's a pretty famous guy.
Yeah. So I used to work at
Yeah.
his startup, and he got placed in Siemens Healthcare. So he was in the R&D department, and it was like a core job. And he was telling me on projects that he was working on, and the kind of projects he was working on was very intense and very interesting. So that is when I started kind of researching about core jobs and non-core jobs, how different it is. Because when I was in second year, I had no clue what was core, what was no non-core. I had no clue about it. But uh, since you said about impact, how core jobs can impact technology, how core jobs can impact the world. I can definitely relate to what he was telling me because the kind of projects he was working on. So that one point which you said is very valid, and also it makes sense for people. Like a lot of people are, they join engineering only to earn money and look after their family. So for those kind of people, I think mass is on a non-core job, or mass recruitment fits those kind of people. But for people who are really interested in engineering, who are really interested in building stuff and really interested in improving technology, they should not miss out on an opportunity of joining core jobs if given to them. Right. So, okay, that was about the significant difference between core and non-core placements. Now, tell us about how you prepared yourself for these kind of core jobs, because I knew that you were not interested in mass recruitments. You were always into electronics, always into core stuff. So, how did you prepare yourself to get into core companies?
So yeah, I would say if you want to get into electronics as an industry, right, you first need to identify the domain where you are interested in. So whether you are interested in firmware design, or you are interested in digital front-end design, or you are interested in the back-end process. So if you have to boil, once you boil down between these three domains, right, you start preparing accordingly. For embedded system domain, you need to know about more of the system level work, and all the front end and back end design is masked at that process at least.
Mm.
And there are a lot of companies working in this domain. To point out, Analog Devices is one which works in embedded domain. Honeywell works in embedded
Mm.
domain. So these are the companies you should aim for. Then when you come to digital design, or the process where you the front end design of a system, that's where companies like Synopsys, Intel, I'd say AMD, Nvidia, all these companies come into designing things. Qualcomm also. So these are domains, companies which offer digital design roles, and the other end of it is the back end design. All the companies which work in front end also mostly work in back end as well. And apart from this, there's also networking roles, communication related roles, probably Airtel, BSNL.
Mm.
There are a lot of these companies which work with
Correct.
communication and networking related domains. So the preparation for all the domains are very different in nature. But if I have to point out a process to be followed, right? There's a big difference when you come to placements and the way you take up any other exam.
Mm.
For an exam, you just prepare from the syllabus and you write it out. Yeah, probably some questions might come out of the syllabus,
Correct.
but in an interview, right, it's not a pass or fail scenario. No interview has a binary output. Yeah, you will get into it, but out of it you learn something.
Mm.
So if you have to prepare for an interview, at the first point is you have to change your mindset that this is an exam. It should be like a skill development process. First, you should start with developing your skills about all the domains. You need to know basics of all the domains to understand where you stand as an engineer and where your passion is towards. For example, I would say my passion is in front end design. or probably the system level design as well.
Mm.
Then I should see where I stand as an engineer in the whole of the development process in electronics. So first you need to understand the bigger picture. Then you come into the domain which you are interested in and start researching more about the domain. First, understand the domain, like understand what you do as an engineer there and what your role is. Then you can get into learning about the various subjects which come in there. For embedded system, you need to learn lot about the various processes followed in system level design, interfaces, the you know, communication systems there, and also when it comes to digital design, right? I can point out to a lot of a lot of subjects to be concentrated upon here because this is one domain which is rapidly growing in the VLSI industry, and recruitment is happening in a very big scale in the digital design domain at least.
Mm.
So if engineers are concentrating on this domain, then they should know about VLSI. They should know about analog, how transistors or MOSFETs work, and then they should know about how from these transistors logic gates are derived, and from there how logic circuits are derived. That's where you have to learn your digital electronics. From there you have to learn about VLSI as an industry, how the flow happens, and then you need to learn about Verilog and System Verilog, which are the hardware description languages. Then you need to know some amount of, I would say, verification processes as well, to be very specific. If you know the basics of it, you can have a heads up among your competitors.
Mm.
Then also you need to know some amount of, I'd say, verification environments as well, like UVM for an example. You need to know, I wouldn't say you need to know entire of that domain. You need to know the basic process of it. And then when it comes to back-end design, right, your analog knowledge and also the knowledge of the entire VLSI flow is very important. So someone who's interested in layouting, PNR, and these processes, right, they need to concentrate more on, I would say, physical design aspects. And also material science is one added advantage to an engineer working in VLSI industry. It helps you understand the various processes which happen in the VLSI industry. Apart from this, for networking and communication related roles, yeah, I would say it starts from your field theory subjects where you learn about all the basics of how field theory works, and then you learn about antennas, wave propagation, and these aspects. And then you obviously have to learn about DSP communication related aspects. And then I would say communication networks at a larger level, how it works from the higher level. All these concepts have to be discussed, or I would say briefed upon before you get into any networking or communication related role. So first, I would say you have to sum up the process first, decide your domain, know where you stand, and prepare for it accordingly. And be an engineer who is able to answer about any domain. You should know the basics of every domain so that you can at least try to answer something which is asked in an interview.
Okay. So it's something like explore and know what you are good at, know the fundamentals of each and every domain that you explore, and then be a master of one domain. So that is basically how it narrows down to one domain, and also it depends on your interest, obviously. So yeah, uh, was Synopsys your first core company, or have you rejected any other offers from other core companies?
No, Synopsys was my first core company, so they came very soon,
Mm.
and I would say I'm very glad that they came very soon. But yeah, after Synopsys, I did try for some other companies because initially I had got only an internship offer from Synopsys. But yeah, not once, they gave the full-time offer also. After some time, when I researched about Synopsys, how the work-life balance there and how the work culture there is, right, I had decided that Synopsys is the place for me to start my career as a professional. So yeah, Honeywell, I did get an internship extension and PPO offer from Honeywell. But at that point, yeah, I decided that I wouldn't be getting back to software for
Mm.
professionally starting my career. And yeah, from the beginning itself, electronics was my interest, and that's why I rejected Honeywell as an offer, because not because the work life wasn't well. I enjoyed the 2 months of internship I did there, but software as a domain itself was not my interest, so I had to give up Honeywell and choose Synopsys. It wasn't a tough decision because they were completely two different domains.
Mm.
Yeah.
Yeah.
I would say I was lucky that I got Synopsys initially. I didn't have to go through the pressure others went through during the placement process.
Okay. Moving on to the next question. What are the tips that you can give for juniors? Tips on the number of, not the number, the kind of projects they have to work on, and how, I mean, you've already told how people have to prepare for placements. But yeah, so tell us more about the tips. How would you give tips to juniors to get placed at core companies?
Okay, so I would say not just to juniors. If I would go back, if I assume that I go back in time and tell myself how I can correct this 4 years,
Mm.
not correct, how I can improvise these 4 years of engineering, right? I would say in first year, just don't mess up your mind about what you want to do. Nothing big happens in first year. Just try to explore all the domains. Every domain is equally important. That's when you find what might be your domain of interest. Probably electronics, probably mechanical, computer science. And it's no sin that you are in electronics and you are interested in mechanical. You can equally learn mechanical as well. There are a lot of options in electives where you can choose
Mm.
interdisciplinary domains. So I think an engineer should focus on trying to find that domain of interest in the first year. Because probably out of peer pressure or parental pressure, they might have chosen a domain which they might not be interested in.
Correct.
And if they continue to be in the same domain, it might end up as a disaster. So in your second year, right, as an electronics engineer, you would be introduced to all the basics of electronics like analog electronics, digital electronics, your field theory, all these basic concepts of every domain. So that's the time when you have to strengthen your basics, concentrate on your curriculum very well, don't ignore it, because that's when the basics strengthen up and it will take you to a very good placement in your fourth year or third year end as well. Towards the third year, you're introduced to concepts like DSP or mixed signal design, VLSI, these higher level of subjects. That's when you have to understand the various domains that exist in the industry as electronics as an industry and try to figure out on a rough scale where your interest lies in and try to educate yourself more on that domain. Yeah, I would say in second and third year, a person should concentrate on their curriculum if you are interested in electronics because every subject you study there somewhere affects your work life as well.
Mm.
And towards the fourth year, right, you should concentrate more on trying to achieve mastery in one kind of domain, probably digital design, embedded systems, or backend design, and try to learn more about that domain, solve questions. Probably there are a lot of online websites which offer quizzes and tests based on gate kind of questions. You can as well take a gate exam if you are interested. You may or may not get succeed in the exam, but the preparation for it will help you in placements, even if you're not interested in gate. And the moment you start preparing for gate and solve quizzes based on your domain, right, you'll get confidence on these questions. And once you enter the placement cycle where you have to take up tests and also go through the interview cycle, it will be an added advantage for you. And I would suggest everyone should do this. And about the projects, right? I would like to add a point that there is nothing like a resource or fund which you need for a project. If you have an idea in mind, right, you should just start it.
Mm.
The resources and funds come on the way. If your project has potential, the funds will find you actually. If you have your potential, you can probably approach the innovation cell in our college, probably approach professors, institutions which offer funding. So there are a lot of sources you can get funding from. And it's actually very easy in the current
Mm.
day. So that way, you shouldn't stop yourself that you don't have resources or funding. There are a lot of EDA tools which are available, licensed in our college, and as well, it is available. Some of them are offered open source as well. So you need to explore these tools and try to complete your project. So I feel the only thing that's necessary to start a project is an idea. Everything else can be procured in the process. So do more amount of projects, do courses which are aligned with your domain and highlight them in your resume and I'd say one thing that is common a lot. I've seen a lot of people do wrong in is their resume, right? They almost dump in everything that they have done, but it is not so. You have to point out the things which interest the employer. I would say a VLS industry person is not interested to know that you have worked on some software project which is not of interest to that domain. So mention it, but highlight things more in your resume, make it more appealing, and that way, if you're not good at presentation skills and if you're not able to speak out in a crowd, then try to focus on that as well because that matters too. If you're in an interview and you're put on the spot and asked to answer a question, then you might be knowledgeable in that question and you might have the potential to answer it off the interview, but all that matters is how you perform in the interview. So try to focus on that, speak out in crowd, try to participate in discussions, and also attend workshops, give workshops if you are knowledgeable in a domain. I'd say all of this will help you in the placement process.
Fantastic. I mean, that point on, that point where you said that your resume has to be modified according to the employer that you're applying for. No, not a lot of people do this, and it's really interesting that you told this to our viewers. So that is very, very important because as a recruiter myself, when I'm looking for people to recruit for a marketing position, I don't I don't want if they work for a technical role somewhere or something else. It's good that they know something, like related to technology, etc., etc. But I'm looking for marketing, and I know what they have done with respect to marketing. So that's one good point. And also, you said public speaking. One biggest thing that I look for in my team is how they communicate. It can be in any language, how they communicate, how they present themselves, how they understand the vision of the company. And it's also better, it's also a must for employees to understand the vision of the company. The Once you get into core jobs, because there's going to be a lot of pressure, small team, you're going to be working on core technology. So it's also important that you align yourself with the vision and mission of the company or a startup. So yeah, again, coming back to public speaking, that is one which you really have to upskill yourself in. This is, of course, to the viewers. So public speaking, communication skills, soft skills. So hard skills is fine, but without soft skills, you won't be able to present yourself anywhere. So it's always a must on learning how to present yourself and communicate well. Right. So last question to you, Bhargav. I know it's been a very few days. It's been a very few days since you joined Synopsys. Uh, from your little experience from Synopsys, tell the viewers on what to expect from core jobs. What are the kind of expectations they need to have on themselves and the company?
Okay. So first thing I would want to tell all the people who want to work in code, right? First, stop comparing yourself with software engineers because pay-wise there will be difference. Not much of difference to this date. It's almost reaching the pay of software engineers as well. So don't compare your pay with software engineer. That's not good. That's not expected as well.
Mm.
The second thing is be prepared to explore every domain that the company works in and try to find how you can contribute to every of things. Once you enter a company, right, it's not that they give you some work and you start working on it and try to complete it on time. That's not what a company expects out of you, or at least I wouldn't want a person who comes into code to think that way. You should see how you can contribute yourself to the company in the best manner. In every manner is possible. As a young person, I myself look at exploring a lot of topics. This is the age, or I would say, once you come out of engineering, this is the age we have a lot of enthusiasm to work on everything which we are interested in. So don't let that enthusiasm go waste. Try to explore everything and take up every opportunity that comes your way. So try projects of your work. Also try doing research. There are a lot of scope. There's a lot of scope for research. There are a lot of professors who work on weekends on projects and need research assistants. Explore all the domains. I'm sorry. So explore all the domains and explore every opportunity you have. I think 20 to 30, this is the age, or I would say 20 to 35, 40 as well. This is the age where the enthusiasm is max in a person, and you should explore every opportunity that comes to you. And as a company, right, a Synopsys, I would say, has the best work culture. We have a lot of BMS people here, and I'm very happy as a employee at Synopsys. I work on a lot of projects. As an intern as well, I've been given real-time projects and I've contributed to the company. So that's one thing I'm happy about. And as a full-time employee, I know I will be enjoying this journey. I don't know how long it will last, but as long as I'm in this company, I know I'll enjoy it. And that I can assure you for sure. And also to anyone who comes into Synopsys, I think there are around 8 juniors who are already selected to Synopsys
Oh,
currently in our college itself. And I'll be expecting to see them in our uh, campus soon in next year. Yeah, I'm pretty excited that this culture of BMS students being in Synopsys is growing, and it's proud to be BMS students that our college has potential to contribute to the industry in such a manner. And I wouldn't say just uh, our college. There are a lot of college people we meet in a company, and that's where the networking develops, and we get to understand the interests of every person. And once you get into a company, right, even it doesn't matter if you're introvert or extrovert. Try to speak to everyone,
mm,
even if you're an introvert internally. But you should that shouldn't stop you from speaking to people, because in a company it's all about teamwork. There's nothing like as an individual you succeed and the company stays back. If the company grows, even you grow. If the team succeeds, even you succeed. So look at the bigger picture. Like you said, I would agree to that. Understand the vision of the company, what the company looks up to, and what the company expects out of you, and try to meet it accordingly. And as well, in the process, enhance yourself. It shouldn't be that you contribute to the company and you are stagnant in your learning. It shouldn't be so. Try to learn more and also contribute that learning to the company.
great, amazing. Thank you so much, Bhargav, for such an insightful conversation. I am sure that our viewers have a lot to take away from this podcast. Thank you so much for appearing in this podcast. And viewers, that's it from my side. See you next week with one story at a time. Thank you, Bhargav. Bye bye. See you.
Thank you, Sarang. Bye.